All right, good morning, everybody. How are you doing today? Come on, you guys could do better than that. Good morning. I'm sure everybody got some sleep last night. You had a good day yesterday after the conference. Went out, got some drinks, got some food. Yeah? Okay. So I'm going to do my best to keep you guys awake and entertained as much as possible. My name is Cecil Phillip, as it says under there. I'm a cloud developer advocate at Microsoft, which pretty much means I talk to a lot of developers and a lot of companies and try and understand what are some of their pain points and hopefully we can make those better for you. Now, we're going to be talking about what's coming in C Sharp 8. So as you might know, C Sharp 8 is coming out a little bit later, along with the .NET Core 3 release that's coming out. But right now we have a preview that has some of the features that we could try out. So I'm going to show you some demos and talk about some of those features that we're going to be able to play around with today. Now, before we want to do that, I want to start talking about like the language strategy. I think it's important to talk about it because every time there's a new version of C Sharp or a new language feature, I'm always like, oh my God, like why is there a new feature? Like why do we need more stuff? Like my language is fine, like stop changing it. And so it actually turns out, well, the team understands these things and they think about it. And so when I spoke to Mads, one of the things that he told me, well, three of the things that he told me was the way that they look at designing the languages, they don't ever want the language to become stale. They don't want the language to fall behind in features or, become something that, you look at as an afterthought. And they also want to look at the language as something that they can evolve for all of developers. If you think about C Sharp today, like we can run C Sharp on IoT devices, we can run it in the cloud, we can run it on mobile phones. You could do Unity games if you're building anything with Unity. So they try to create features that will be good for all developers and not just focus on one particular use case. And then also too now with .NET Core being open source, with Roslyn being open source, with a lot of these tools being open source, they want to have more community involvement inside the process. And so actually what you could do, if you're ever interested, you can go to the C Sharp language repo that's on GitHub, and then you can look at all of the proposals for the new version of .NET, the new version of C Sharp that's coming out, and even some features that they haven't even spoken to us about that yet. You can see what the proposed syntax might look like. You can see what the behavior is, and it's all out in the open, so you can understand like what are the type of things that they're talking about and thinking about as they're designing the language. And again, this is all just on GitHub. And I have links to this and some other resources that you can copy at the end. Now, before we get into C Sharp 8, let's talk about 7. So 7 was a little bit different from some of the typical releases that they usually do, right? Because there was a C Sharp 7, and then there was a 7.1, and there was a 7.2, and then there was a 7.3, and then now we've rolled up and we're coming down to 8. So I think before we talk about 8, let's just look at some of the few features that I think are particularly interesting, particularly for some of the stuff that we're going to talk about a little bit later. So one feature from 7 I want to point out that I think is pretty interesting is that, we all know that we could create Lambda functions. Lambda function is not new, it's nothing exciting, it's something that we've always had. And as you can see, like we can declare the Lambda there at the top, we can assign it to an action or a func of t of some sort, and then we can call it like we do any regular function. Well, with 7.0, they allowed you the ability to create local functions. So local functions are a little bit different, right? So it's essentially just like a function declaration, but it's within the same scope of whatever it is that you happen to be doing. So you can have a function declared inside of another function, right? So it's only going to exist within that scope. So now you're thinking, okay, well, you just added another reason for me to declare functions. Why would I want to use this? So it turns out this actually comes with a couple of benefits. So one, I don't know if you noticed, but with Lambda functions, you can't create iterators with Lambda functions, right? But you could do that with local functions. Also, local functions actually allocate less memory than Lambda functions do. So if you're in a situation where you're worried about performance and allocations, you could definitely check out using local functions. And another thing too, if you're ever doing anything with recursion, it's a little bit easier to do recursion here with local functions because we already have the name and the method signature is just a part of the declaration of the function. So those types of things are just a little bit easier to do with local functions. Next thing that I've seen a lot, have any of you ever written code that looks like this? Get awaiter, get result. You don't have to lie. You can tell me, to be honest. No? Yeah. Yes, I know. I look on GitHub. I see a lot of people write code that looks like this. Now, the reason that this is not good is that because, well, you want to run your async code in an async fashion, right? Like, essentially, I'm calling my async function, but I'm blocking, which to me kind of totally defeats the point of it being async in the first place, right? I lose a lot of those types of benefits. So in C# 7.1, we now have the ability to do async main, right? And so now we'll just take care of all of that state management for you, and then you can just annotate your class with an async keyword and then return a task. And then now you could just run async methods inside of your main, just like you would any other method in your application. Another known feature that I find a lot of people don't really know about, we have the ability to do ref returns and ref read-onlys. So what's a ref return? So usually when we pass variables, right, particularly when we're talking about like ints and numbers and value types, we usually copy them, right? Like I pass it into a method, I pass it out of a method, and I'm talking about I'm creating copies of these things. So you might be in a situation where you don't actually want to have to copy that information. Maybe I just want to return to you a reference for that particular memory location. Very much similar to how we do with reference types, like we do with classes and things like that. Well, so what we can do here, if you see at the bottom, I could say my method returns a ref. So here I'm just returning an integer, which is just an integer I got from this array. But instead of copying the value of that integer out, I'm just giving you a reference to that particular memory location. So now, again, you can think about when you're working with devices like IoT devices and things like that, I don't really have a lot of space to be copying things back and forth. We can have a really efficient way of sharing data without having to continuously make copies. Now, one of the issues here is that, well, if I'm giving you the exact memory location, I'm giving you the exact reference to that piece of data, that means that when I pass it out, you might want to change my information, and I may not want you to do that. Right? Maybe I want you to just look at it, but I don't want you to touch it. So one of the things that we could do, if you look at the signature at the top, is I could say that this method returns a ref read only. So now I'm returning a reference to some value type. I'm not copying it, but then I'm also letting you know, and I'm also letting the compiler know that you can't change this, right? So again, we have a little bit of, I'm sorry, what? Oh, yeah. So now here we could let the compiler know, we can let you know that this is not something that can be changed. And so those are some interesting features that I like in C# 3, and we're going to keep building on those as we go forward. Now, let's start off with talking about pattern matching. Now, pattern matching was something that was introduced in C# 7, and it's something that we continue to build on with 8. How many of you use pattern matching? Quick show of hands, or understand what it is. Not many of you. Okay. So pattern matching essentially is a way that I could test the value of some type or test the state of some type, and then now I can do control flow based on that, which it sounds kind of abstract, right? Because we could do that with ifs and switches and things of that nature. But it's actually an interesting way for us to look at like crafting our applications. Now, in C# 8, we actually added the ability to do switch expressions, and I'll show you what that looks like, because that's a new interesting way of doing pattern matching. But here, I'm going to show you a really quick example. So if we look at it from top to bottom, I have a method, and my method is accepting an object, right? So essentially, it's untyped. I don't really know what it is. You could essentially be passing anything into this operation. And now I'm going to say, I want to switch on this type, right? So I'm switching on this shape. Now, if you look at my different case statements, like that shape could be a square, it could be a circle. I could have some other type that I've defined. And I could say here in my first case, if this shape here happens to be a square and, or when the side is equal to 0, then I want you to do something. Or if it's a circle with a radius of 0, I want you to do something, right? So essentially what's happening is that my switch statement is inspecting this type, this object that I've gotten on, the instance of object, and it's going to say, hey, if you match any of these types, then I want you to instantiate it or cast it to this variable. And then now we could do things like we could start expecting the properties and whatnot and start to do some interesting things here. Now, what I want to do is I'm going to jump into a really quick demo to show you a little bit more of a concrete example of how you might use something like pattern matching. All right, so first thing I want to do is, here I already have a CS project and a thing set up. And now this is set up to use C# 8. And you know that because if you look here, I have this thing in my MS build file that says Lang version. Oh, sorry about that. It says Lang version 8, right? Now I'm going to open up a really quick sample I have on pattern matching. So here, and let me know if the code is not big enough. Let me know, and I'll just make it a little bit bigger for you. Now here, it's a very simple operation, fairly trivial example. But what's happening is I have a type, a class called person. Person has properties first name, last name, middle name. That's all that's inside of there. And now I'm saying here, well, if the first name is null and the middle name is null, just return the last name. You know, if the middle name is null, but the first and last name are not, then return the first and last name, and so on and so forth. I guess you kind of get the point, right? Now, let's see how we could change this code a little bit and use some of these pattern matching features that I've been talking about. So what I want to do is I want to change this, and I want to start using switches, right? So I want to switch on the type of, well, not on type. I want to switch on the instance of person. Now I'm going to take these one at a time, and we're going to start converting these to use pattern matching. So I'm going to grab this first line that's here, move this up in here. All right, and so the first thing I want to do, I don't need this if statement anymore. I'm going to get rid of this, and I'm going to bring this up to the top, right? Now I'm going to need a case statement, right, because we're doing cases. And now I need to match it on some type, right? So you see in the previous example, it was shape, circle, square, whatever the case is. So I'm going to say case person P, right? So I already know this is a person, but bear with me for a second. So case person P, and now I am going to do something like this. Case person P, and if the name, I'm just going to say if the name is null, comma, and I'm going to take this out too. And if middle name, colon, is also null, boom, colon, then I want you to return this thing that's here. Hold on 1 second. Okay. Oh, I got to put this P in here. Sorry about that. P. Great, right? And now I've created a case for this thing. It's giving me red squiggly lines because I'm not done yet. But I'll show you what I'm doing in a second, right? And so now I could say, well, hey, if case this is a person, right? I know this is a person. If the first name is null, the last name is null, I want you to return that last name. Actually, this is supposed to be p.last name, right? Now I'm going to come down, and I'm going to start changing this last one. I'm going to move this up 2, right? And I'm going to do the same thing, right? So I am going to say case person, right? I could keep reusing that same p identifier if I wanted to, right? And I want to say for, if I do p.last name, that thing, oops, come back, right? Now, p is not equal to null, right? And so I need some way to identify any value that's not null. So one of the things I could do is I could use this underscore. Now, the underscore in C#, this feature came out in some version of C# 7. This is called a discard. So this is essentially saying, like, I don't care what value this is, right? So I have a null value and then some other value, right? So as long as name is some other value, I don't know what it happens to be, right? And this one is also null, right? And then I'm going to do the same thing with this. p.last name. I'm going to discard this too, because I don't care what that is. And I'm going to bring this return to the top. Okay? And now I'm going to say, I want you to return that, right? Right? So essentially, as I'm going through, notice that the syntax is starting to look a little bit weird for C# developers, but bear with me, because we're gonna take it all the way down. Now I'm going to do the same thing with this, right? So I'm going to add another case statement. Probably pick up the pace a little bit. Person p, right? And I'm going to do the same thing like I did here before. Right? So I'm going to say p.firstname not equal to null, right? So I'm going to use a discard. Discard just meaning like doesn't matter what this is, right? And now I'm going to do p.middle name is also not equal to null. So now this is the case where I have all three of the values, right? And then I'm going to do the last one here. P last name is not equal to null. Oh, why does that look like that? And I'm going to discard that too. Right, and now I need to change this. Forgot to change this. This is supposed to be a pair program exercise. You're supposed to let me know when I forgot to rename my variables. Right? And so that essentially now I'm starting to go down and go through the exercise of making this a little bit smaller. Now, you might be wondering, okay, well, what about this thing? Right? What do we do with this? Right? So now I could take this back up. This is actually would just be the default case. Right? If you're familiar with that would just be like the default case that's inside of here. Now, one of the things that I know I want to do is, well, I know that these things are all people, right? Or I know this is all a type of person. So I technically don't need this person thing that's here, right? So let's get rid of this. Right? I'm going to try to make this syntax look a little bit cleaner. I just got rid of that p, so I really don't need that anymore. Right? And now I could just say just return person, not last name. Spelled that wrong. And I'm going to do the same thing for here too, right? Like, don't need this p anymore. Right, returns. Sure. This is supposed to be curly. Return. And I'm just going to say, I want you to return this person. Return this person. Okay. And then last time, I'm going to do it for this one. Remove that. Remove that. Remove that. Change that. I'll change this to person. And so now, and here I'm using string templated strings here in C#. And now you can see here now, so it looks a little bit different now, right? So now my case statement is just, instead of doing logic based on conditional logic with trues or false, it's doing it based on the pattern, right? So the pattern is, again, like if this person has a first name of null and a middle name of null, return the last name. If it has a first name that has a value and a last name has a value, but the middle name doesn't, then I have another pattern that matches that. And then my last pattern, well, my second to last pattern is going to say, well, if all of them have values, then I want to do something, right? So again, essentially, I'm applying pattern matching to now help me figure out, oh, what exactly is my application is going to do. Now, why would you want to use pattern matching versus doing something like just the if-else statements that we had before? Well, so let's say I take this default case out, right? If I take this default case out, essentially what's happening here is that, notice like I'm getting this little error. And it's letting me know that, well, not all of my conditions have been met, right? Like the compiler is intelligent enough to let me know that, hey, well, you have these patterns, but like there are different permutations that you're missing. If I was just doing simple if-else statements, well, I might have missed one by accident, right? And that might not have come up until I did like unit testing or something like that, right? But again, because we're using pattern matching, the compiler is intelligent enough to let me know, well, hey, something else is happening here, right? So that's pattern matching. Now, what I've shown you so far, this is available in C#7, so you could do this today. One of the things that's really interesting in C#8 is that we can do what's called switch expressions, right? So this essentially right now is just like a switch statement that has all these returns. What I could do, what if we could, well, you could flip this around a little bit, right? And what if I wanted to return person, right? Within the context of that switch, right? So let's see how this would work. So first thing that I'm going to do, I'm going to remove these case statements from here, right? Next thing that I'm going to do, I'm going to remove this return statement. I'll remove this one too. And I'm going to remove this one too. Bang. I'm going to change these to commas. Great. So here's my first pattern. Here's my second pattern. Put a comma here. Now I can't do defaults like this anymore, so instead I'll have to use that discard I told you about. Remember, the discard just means like what any other value or whatever value is left. So notice now, like it's a little bit more compacted now. Like I have a single return statement instead of like 3 return statements. And then now it's just going to say, based on whatever pattern it matches, I'm going to return that particular value. So again, it's just a different way of thinking about how we do control flow based on the types of our applications, based on the types of our objects in our applications. Now again, this is a very contrived example, but you can imagine if I was matching on something like, again, this was different types of employees or different types of shapes or different types of events that I was looking at in my application. Now I could just match on these different types or match on these different properties, and based on that, I'll have a different way to set up my control flow inside of my application. And so that is how we do switch expressions in C#. All right, let's keep it going. All right, so a really big feature that a lot of people are really interested in is nullable reference types. Now, as you know, like if you have a object, anything that's a class, you know what I mean? Like it's passed by reference, and so that object can have a value or it cannot have a value. If it doesn't have a value, then it means that it's null. Now, a lot of the times, we might be passing objects around, and those objects happen to be null, and then you try and reference some property on them or call some operation on them, and that ends up throwing an exception, null reference exception. And now you're looking in your stack trace and you're trying to figure out, well, what happened and why is this thing null, and then what's the source of this bug? Well, so one of the things that we did was we made it, we gave you the ability to express the intent of whether null is an actual value or not, right? So what does that mean? So today, if I created a new person, like you saw I did there, I could say, person P is equal to null, right? After I turn this feature on, then null becomes, I have to say, well, hey, do I want to allow it to put null inside of that object, right? Is that something that I want to allow it to do, right? And so what that does is that, well, it helps us hunt down these null reference exceptions. And now the compiler now is intelligent to know, well, hey, this thing was assigned or was never assigned. You know what I mean? You might want to fix this. And now we start to see like warnings and errors and things like that like fall into your application. Now, one of the great things about this feature too is that it really changes the way that you write code and where you put your guards. And so it's actually an opt-in feature. You have to turn it on, right? So, when you start using C#8, it's not just going to start giving you warnings and errors about nullable reference types. You actually have to turn it on. And so let me show you really quickly what that looks like. All right, so I'm going to show you what my person looks like really quickly. So like I said before, first name, last name, middle name, right? And it just has those 3 properties, each of them are strings, nothing special going on there. Now, what I want to do is I'm going to go into my CS proj, and I'm going to turn on nullable reference types. And the way we do that is by turning on, wrong button, by enabling nullable context options, and I'm just going to say enable. Now, I'm actually using the preview 5 of .NET Core. In the next preview, this is going to change from nullable context options. It's just going to say nullable because that's just so much easier to remember for most people. But for the preview that I'm using right now, so this is how you turn it on. So now it's going to look at all of the types inside of in my project, and it's going to try and figure that out. Now, you actually also have the option of doing it on a per file basis. This one does it on a per project basis, but you could do it on a per file basis too if you wanted to. So which is good for large code bases. So if you wanted to incrementally turn this feature on and inspect your code a little bit at a time, then you should be able to do that too. All right. Now, what I'm going to do, I'm going to head over, now that I turn that feature on, I'm going to go back to my person class. I notice now I'm starting to get these little yellow squiggly lines underneath my class. And it's saying, non-nullable property first name is not initialized. Right? So why is this happening? So I have this class, and I haven't defined a constructor. So if I don't define a constructor, that means I have a default constructor. Right? And so my default constructor is going to initialize all these strings to nulls, because they've never been assigned, right? But I just turned on nullable reference types, right? So that means that, well, null is not a valid value for these types, right? So I need to explicitly say, well, what do I want to do with these values, right? So what I'm going to do is I can just create a really quick constructor here. And I'm just going to say person, and I'm just say string first name, string last name, right? And I'll just assign these to some values, right? So I'm going to say first name, not that one, the big one, is equal to that. And now I'm going to say last name is equal to that last name, right? Okay, great. My squigglies are gone, but like it looks like it just moved up to the constructor, right? So let me put my mouse over here and see what this says. And it says non-nullable property middle name is uninitialized, right? So I initialized the first and the last name, but now the middle name still has a problem. Well, one of the things that I could do is I could just add a question mark here, right? And I can say, okay, well, this type is nullable, right? So that means that null is an acceptable value to put in last name, because I might have a person that doesn't have a middle name, right? So you have a first name, I have a last name, I may or may not have a middle name. So null is an acceptable value for me to put in there. Okay, so we've set that up. Now, if I come over to this operation that's here, so you can notice here that what I'm doing is that I'm just, again, very similar to like that last demo, I'm just printing out my first name, my last name, and my middle name. And it looks like it's supposed to have an error here, but sometimes you got to kick this thing in the butt a little bit so it starts to show you. There we go. Great. So now it's saying, hey, I'm possibly referencing a type that's nullable. Because remember I said that the first name cannot be null, last name cannot be null, but the middle name might be. So the middle name might be null. If I'm calling it here and I'm dereferencing it, I'm trying to get that first initial out of the middle name, but I'm not doing any null checks, right? So how do I fix this? I have to do some null checks. So I have to say something like this. If, I can do like if person dot middle name is null, right? And I'm just going to copy this. So the person dot middle name is null, let's just not do it, right? And if the person is middle name, if the middle name is not null, then I can grab it, right? Now, we could even take this a step further if you wanted to. Unless we wanted to apply pattern matching, just like I showed you a little while ago. So I want to apply pattern matching to this thing. So what I could do is I could say return. I'm going to return person, switch, right? So we're going to do a pattern matching sample. And I'm going to say, I'm going to grab the first one just like I did before. I'm going to move this up, right? And I am going to say, if the middle name is null, so I'm going to just do colon null, then I want you to return that. And now I'm going to grab this last one. That's supposed to look like that. There we go. Now I'm going to grab this last one. And if the middle name is, oops, what happened there? Okay. If the middle name has any value, right? I'm just doing a discard. I want you to return this thing. Pull that back a little bit. Boom. Switch statement. What did I do wrong? I have too many. Okay, there we go. This, gotta fix that. Which one? I'm sorry? Line 4. Oh, where did that come from? Did I put that in? Oh, it's weird. Okay. Yeah, where did all those come from? Sorry about that. All right, and now I don't need that. Great. Am I missing one? Still missing one. Oh my God, Jesus Christ. That one matches that one. This matches this. If only I had something that would do this for me. This matches that. Great, there we go. Great, it works. So, right, so now I have pattern matching and nullable reference types helping me determine, making sure that I'm covering all the cases. So now as I'm returning, again, I'm just trying to format a name, but now my code is a little bit more reliable, right? Like I feel a little bit more comfortable with this. Not to say that you're not going to have any bugs, but I'm less likely to have issues with like nullable reference types. Right. So again, it's just a feature that I like personally because I think it lets you talk about very explicitly like this is the intent of this type, right? Like this is how I expect it to behave and this is what I expect it to do. Right. Now, next one I want to talk about. Let's talk about working with collections. Now, if you're familiar with some other languages, you might be familiar with the concept of slicing and getting ranges and specifying indices and things like that. Now, with C#8, we're getting the option to do ranges and indices. In 2.1, we have span of t and memory of t. Now, if you're not familiar with those are some really interesting types that allow us to get like a subsection of a collection, but without copying, which is important, right? Like we could always get like, if we were doing strings, we could get a substring, or I could always say, hey, give me from this position to that position. But we'd always end up copying. We always end up using additional memory. What we get from span of t and memory of t is I could get a collection or some collection of objects or some continuous set of bytes. But then now I just get like a view into that section of the larger array or the larger collection, right? Like I don't copy, I don't use any additional memory. And again, for situations where you're working with devices that you don't want to be doing a lot of copying or allocating a lot of additional memory, this might be very important for you. Now in C#8, we get two new operators. We get the range operator, which is that little tilde look inside there at the bottom. And then we also get that indexing operator, which is those two dots. So here's a quick example of how you'd use indexes, for instance. So here I just have a list of strings, right? The quick brown fox jumped over the lazy dog. Right, and so we're familiar with using regular indexes, where we go from 0 to 8, right? The total is 9. Now with indexes, with this little tilde, we could start counting from backwards, right? So again, we're used to going forward. Now we can start counting backwards. So now when we apply this index with a range, we can start doing things like this, right? So I can say I want the first 5 words out of the list. Right? I can also say that too. I can omit the 0 because we just could assume that's there. I can have words. If I just put the 2 dots, like I can get everything. But look at this last one. This last one is interesting. I'm going to say I want to start executing. I want to exclude the last 2 things out of the list. Right? So now I'm only getting, like remember what I said, like I'm only getting like a subsection of that list, right? And we can combine these in very different ways if you want to do things with collections. One of the things that I think this is really useful for is if you ever done anything with parsers. Anybody ever written a parser? Like a JSON parser, a XML parser, anything like that? So like usually when you're working with collections of strings and you're having to, get substrings and things of that nature, a lot of the time you're doing a lot of copying, right? Like you're copying a lot of, strings into smaller strings. Well, with this, using stuff like this and using span of t and things of that nature, you reduce the amount of copying you do, and you also get a really nice syntax for start working with those things. All right, next feature I want to talk about is asynchronous streams. Now, asynchronous streams, if you think about it today, like we're used to, when we have our async functions, like I might say, get people async or get person async, right? And then I'm going to have a task of t that's going to go, and it's going to do some work, and it's going to come back. But usually when that happens, that's like a single event that happens. That's a single call, and it comes back, and it's done, right? What if I had the case that I was continuously getting information, right? And instead of getting pushed the information, I'm continuously calling for it, right? So now I have a collection of people, and I'm saying, or a collection of, I don't know, water bottles, my collection of something. And I'm essentially saying, well, I'm ready for the next one. I'm ready for the next one. I'm ready for the next one. But as you're calling those, like that's actually an async operation, right? Now, we never really had a good way to do this that wasn't blocking, right? Like if you did this today with regular for loops, you'd have to block on that loop. and then go through that data that you received. So now with C#8, we have the ability to do async operations in your for each loops. So essentially, now I can enumerate over that stream of data that's coming in, that list of async operations, and now I could say, hey, give me the next one, give me the next one, give me the next one, right? So now essentially we have like asynchronous iterators. So I'm going to show you really quickly what these interfaces look like. So like if you're familiar with IEnumerable of T or IEnumerator of T, like these look very familiar to you. The structure is pretty much the same, right? So the IEnumerable returns a get async enumerator, as you can imagine. The only main difference here is that now we're passing in a cancellation token down into it. And then also we have the enumerator here at the bottom that has the current and the move next, right? So with regular enumerators, this would be just move next versus move next async. And then we also too have now async disposable. So that means that let's say I'm doing something like, I know I'm connecting to a database or I'm doing anything that I had to allocate resources. Now I can make sure that that's disposed of after I'm finished going through my for loop. All right, so let's take a look really quickly and see what it looks like to create and use asynchronous streams. Okay, so the first thing I want to show you is, so I actually have a method here. I have a fake data service that, as you can imagine, is generating fake data. And so now what this is doing, if we take a look here, you can see that oh, you can't see that, can you? Oops, sorry about that. All right, there we go. Right, so I have a method called getPeopleStreamAsync. Right, and so what I'm doing is that, notice that I'm returning a type of async enumerable. So like with regular, we've been working with the TPL before. Usually, if you have an async keyword here, you'd have to have like a task of T, right? Well, now because I want this to be a async enumerator, right, or async enumerable, right? Like I want this to be a type of async enumerable, which is totally fine and valid in this case. And now you're going to notice here that, well, don't ignore this. I'm just, this is my fake data that I'm generating here. But then now you're going to see that I'm going to simulate some delay. I'm simulating like a network call or a call to disk, or I'm doing some type of I/O. And here you can see that I'm doing a yield return person, right? So this yield is the important part, right? If you ever created an enumerable before, you can know that yield here is very important. This is what makes the thing iterable. So now here I'm creating this yield after I've called this async method. And notice I'm not having a block or anything like that. And with me calling this yield, this is what essentially creates that async enumerable for me. So let's see what it takes to actually consume something like this. Right, so I have this demo that's here. So I have my fake data service. And right now I'm just calling the regular getPeopleAsync. Right, if you take a look at this really quickly, this just returns a regular IEnumerable with a task of T. So what does that mean? That means that I'm going to make a call. I'm going to get all the people back at one time, right? Now, what if the people all aren't ready at the same time, and instead I want to get them one at a time as a continuous stream? So what I'm going to do instead is I'm going to use my stream version of this method call, right? And then now I'm going to put an await in front of my for each loop. And so that's all you have to do, right? That's all you have to do to consume an async stream, right? So you've seen how you could create an asynchronous stream, and you've seen how you can also consume it too, right? So again, like this is returning a type of async enumerable, and then now I'm consuming it here in my for each statement, and I'm just writing, again, the typical code that I'd usually write. Now, what's going to be interesting, I think, in a couple of months is I know the folks, some folks online in the RX community are working on, I think it's called system.interactive. Are you familiar with rx.net and system.interactive? A little bit, kind of, sort of? Okay, so RX is, so RX is something that came out a while ago out of the same team that built Link. And with RX, they created like some really interesting extensions for doing publish subscribe type patterns, right? So I have some producer that's creating, some data, and then now the client could say, hey, I want to subscribe to this, but now I can apply link operators like select and where and those types of things. And now I'm starting to filter out these things that are being sent to me asynchronously. Now, the difference with asynchronous streams is that instead of subscribing to some type of asynchronous source of information, I'm pulling it, right? So it's like a push versus pull model. So instead of something pushing to me, I'm saying, hey, I'm ready for it. Okay, that's the whole point of the for loop, right? The for loop says, hey, I'm ready for it. Let me get the next one. And now I'm going to say, okay, well, give me the next one, give me the next one, give me the next one. But now imagine if I could do something like, say, I don't think this is going to work today, but bear with me for a little bit. Imagine if I could do something like, say, where P equal to, I don't know, some value, right? Like something like that, right? Like, so imagine now that you have these asynchronous streams and we could start to do filtering and create link operations over these other types of things. Again, very much in the same way that we do with enumerables today with link. So I think that's something really interesting that I'm expecting to come pretty soon. There's actually a GitHub repo that some of that work is happening in. Let me see if I can find a few, just in case you might want to see it. I'll open Edge, because I like using Microsoft Edge on a Mac. And let's go to GitHub. And I think this is in .NET/reactive. Great. And so inside of here, you'll see some folder called, IX, which is interactive extensions, and RX. So again, the push versus pull model. And then they have a lot of different NuGet packages in here that'll add on those query operators from link that'll allow you to do some of these things. Now, the 4.0 is the one that you want, but this one is still beta. So, I'm not quite sure what the state of this is. But I definitely recommend you checking it out if this is something that you think might be useful for some of your applications. All right, let's pop back over to the slides really quickly. So that was asynchronous streams. So those are all the features for C#8 that I wanted to show you today. Right, so we saw pattern matching, we saw how we could do things with async streams, and we saw nullable reference types. Now, there's a couple other features too that are coming down that I didn't get a chance to show you. So one of the things that's coming is we're going to have the ability to do like default implementations for interfaces and things like that I think are going to be really interesting. But if you want to take a look at the code or any of the links or resources, you can copy this URL. I like giving people one URL. And what this URL is going to do is going to take you to a list of a bunch more links and resources that you could use. So definitely check it out. Let us know what you think. And we'd definitely love to get your feedback.